Hi, folks. We're going to take a look at page 260, number 4b. So here they're asking us to find the second derivative of this function here. So this is just the Leibniz notation for second derivative. All right, so in order to do that, the first thing we have to do is find the first derivative. All right, so y prime is equal to. So again, eventually, hopefully you won't need to do this, but remember that this is the same as writing tan x all squared. All right. So if I think of tan x as my u, so the derivative of u squared is 2u, so 2 tan x times the derivative of u, so the derivative of tan x is just secant squared x. All right, so there's my first derivative. So now I'm going to take the derivative of the first derivative, which of course is going to give me my second derivative, which is what I'm looking for. And so here I will have to use the product rule since I have tan x times secant squared x. So the 2 is just a constant. All right, so we can just remove that altogether. And now let's take the derivative of this thing here. So derivative of the first, derivative of tan x is secant squared x times the second function, which again is just secant squared x, plus the first function, which is tan x. All right, times, well, now here I'm going to have to use the chain rule, because again, secant squared x is really secant x all squared. All right, so this is again u squared, derivative of u squared is 2u, so times 2 secant x, and then times the derivative of secant x, and that's just secant x tan x. All right, and so now we could leave it, I would expect you to leave it like this if I said not to simplify. Otherwise, we could continue simplifying because a lot of nice things happen here. So if I distribute the 2, I just have 2 times secant to the 4th x, and then here plus, well, there's another 2 there, so 4 times, and here we have secant squared x and tan squared x. Okay, and that's as far as I'm going to go. I suspect we could go a little further because, of course, secant squared and tan squared are connected by a one of the Pythagorean identities. So you probably could go a little further, simplify this a bit, but I'll just leave it like this. All right, so let's just do a quick recap. First of all, recognize this as the notation for the second derivative of the function, which I find by first finding the first derivative and then second derivative. And not surprisingly, as we find more derivatives, when we're not dealing with polynomials, they tend to get a little more complex as we go along. Okay, that's it for this one.